Hey everyone, and welcome to The Explainer. Today, we are traveling way back to the absolute peak of classical Greek scholarship. We're talking about an era where the very foundations of how we understand the universe, our planet, and science itself were actually laid down. It's a period that reached its absolute zenith with the brilliant minds of two towering figures, Plato and Aristotle. So, we really have to ask ourselves, how on earth did just two men create the blueprint for all of modern science? Well, what we're going to explore today is a pretty dramatic intellectual clash. It's essentially the ultimate showdown between a top-down theoretical approach to the world and a bottom-up, observation-first reality. Here is our roadmap for today. First, the zenith of Greek scholarship. Second, Plato, master of deduction. Third, Aristotle, the empirical shift. Fourth, proving the spherical Earth. Fifth, the zones of habitability. And finally, the legacy of the masters. Let's get right into it.
Section 1. Zenith of Greek Scholarship.
Moving right along to Section 2, Plato, master of deduction. Okay, let's dive into this and set the stage. During the classical period, Greek thinkers firmly believed in a perfectly orderly universe, and they were constantly seeking the underlying mathematical laws to explain that perfection. Thriving in this intellectual environment was Plato, living from 428 to 348 BC, and he is widely regarded as the master of deductive reasoning. Now, what does that actually mean? Well, it means reasoning from a broad, general theory down to a specific, particular fact. Plato insisted that the physical, observable things here on Earth were really just poor, imperfect copies of perfect ideas. He actually believed that the observable world was currently in a state of degeneration, literally declining from its original perfect state. To really understand Plato's mindset, let's anchor his philosophy to a real-world example that he used himself, the region of Attica in Greece. In centuries past, Attica had highly productive soil and these dense mountain forests, which supported a huge population and managed all the rainwater. But over generations, relentless resource exploitation by the people living there caused severe soil erosion and runoff. Fast forward to the 4th century BC, and Plato is looking at this newly barren land. But because he reasoned deductively, starting with his top-down theory that the world is inherently degenerating, he blamed this destruction purely on the natural degeneration of the Earth. He completely missed the fact that human beings were the actual agents of this environmental change. And that brings us to a massive roadblock in early science. What happens when the facts on the ground just don't match the perfect theory? If you only use deductive reasoning, you might just explain away those inconvenient facts as exceptional occurrences, leaving your flawed theory totally untouched. This limitation set the stage for a desperately needed massive pivot in scientific thought. Which brings us to Section 3, Aristotle, the empirical shift. Now, what's really interesting about this slide is how it illustrates the arrival of Aristotle. This is Plato's most famous student and the founder of the Lyceum. But Aristotle championed a radically different approach to understanding the world. While Plato's deductive method dictated that a general theory interprets the particular facts, Aristotle taught the exact opposite, the inductive method. He told his students to go out, gather particular facts first, and use those specific observations to build the general theory from the bottom up. He firmly believed the absolute best way to test a theory was to confront it head-on with direct empirical observation. And Aristotle didn't just observe things randomly. He categorized them. He formulated the world's very first true paradigm for scientific explanation. He argued that to truly understand a natural phenomenon, you need to answer 4 fundamental questions. Step 1, nature. You have to understand its essential characteristics. Step 2, substance. Identify the specific matter or material it's actually made of. Step 3, process. Determine the cause or the process through which it was formed. And finally, step 4, purpose. Understand the function it fulfills within the natural order. This structured logic, it was an absolute game changer. And that 4th step, purpose, leads us directly to Aristotle's concept of teleology. Now, unlike Plato, who thought the world was just constantly degenerating from some perfect past, Aristotle believed the universe was purposely planned by a creator. Teleology is basically the belief that all things are in a process of physical change, actively striving forward toward a final, perfect state or purpose. So in Aristotle's view, the universe isn't falling apart at all. It's actively developing toward an ideal. Let's look at a practical example in Section 4, Proving the Spherical Earth. To really see the difference between these two legendary thinkers, let's look at a very tangible geographic question, the shape of the Earth. Plato was actually the first philosopher to formally announce the concept of a spherical Earth, but his reasoning was entirely philosophical. He argued that symmetry of form is an attribute of perfection, and since the sphere is the most perfectly symmetrical shape out there, well, the Earth must be a sphere. Aristotle agreed that the Earth was round, but he wasn't satisfied with just a philosophical assumption. He demanded direct, scientific proof.
So the crucial point is the actual inductive evidence Aristotle went out and gathered. He literally pointed up at the circular shadow the Earth casts on the moon during a lunar eclipse. He also noted how star constellations actually change their height and visibility depending on whether you travel north or south. Plus, he relied on his theory of natural places. He reasoned that since terrestrial substances like earth and water naturally fall toward the center, while fire and air naturally rise, and heavenly bodies are made of this perfect fifth element called aether, the falling solid matter must inevitably form a ball. This rigorous demand for observable evidence marked a massive, massive leap forward in the Earth's sciences.
Moving on to Section 5, the zones of habitability. And this brilliantly illustrates how Aristotle didn't just stop at the physical shape of the Earth. He also made some groundbreaking contributions to human geography with his concept of climatic determinism. He theorized that human habitability was directly a function of your distance from the equator. So classical geographic perspectives began to map habitability straight to latitude, physically dividing the globe based on temperature and climate. Aristotle proposed a very deterministic zonal division of the Earth. He defined the torrid zone right at the equator, assuming it was this fiery wasteland, just too hot and dry to support human life. Then you had the frigid zones at the polar regions, which he figured were permanently frozen. That left the temperate zone as the intermediate area, which he believed was the absolute only habitable portion of the Earth, known as the Ecumene. Now, obviously, we know today that the equator isn't some boiling, uninhabitable desert that will instantly scorch you, but his underlying method of linking climate to human geography, that was incredibly groundbreaking for his time.
Finally, let's wrap up with Section 6, Legacy of the Masters.
Let's move to how this builds into the big picture, because these ideas didn't just fade away into history, they literally shaped our intellectual trajectory. The cornerstone of scientific geography was unquestionably formed by the erudition of the ancient Greeks. Here is the big takeaway. If general principles and observed facts diverge, the principles need to be updated. This is why this history matters so much to us right now. Modern scientific methodology, where we update our theories based on new factual observations, is a direct living descendant of Aristotle's push for observable facts. Now, while Plato's deductive reasoning played a huge role in the early growth of natural sciences, it is undeniably Aristotle's inductive method that truly unlocked modern scientific inquiry as we know it.
So, I'm going to leave you with this to ponder. Does modern science rely more on Plato's theory-first pursuit of perfection, or Aristotle's observation-first embrace of reality? I mean, perhaps it's a bit of both, right? But understanding this climax of Greek thought helps us understand the very nature of how we seek truth today. Thanks so much for joining me on this explainer, and keep questioning the world around you.